This video is meant for Mrs. Rose's AB Calculus class, and our topic is easy integration with substitution. The idea of integration with substitution is very straightforward. If we have an integral of f of g of x times g prime of x, the antiderivative is just going to be the antiderivative of f of g of x plus c. So it's basically the anti-chain rule. Okay, so what we're going to do is practice identifying in the integrand, so like our function part, in each of the following integrals to fit the pattern of f of g of x, I'm missing in parentheses, times g prime of x. We're going to identify the pattern and use the result to evaluate the integral. So when we look at the integral of 5x squared plus 1 squared and 10x, the pattern we're trying to see is what is like an inside function, what's an outside function. So because we have this squared, this is going to be your outside function. And the part that's inside of that outside function is going to be what we identify as u. So u equals 5x squared plus 1. Then we need to identify what the derivative of u is. Now normally we write the derivative as du dx or u prime of x. So if we write du dx, all we do is take the derivative of u. So the derivative is 10x. And we have that, fortunately, so what we do then is we write du equals 10x dx, so that this part is we can rewrite our integral to be just in terms of u. So if we've done that, now we can say that this integral here, this part is u, it's squared, and this part is du. So we have u squared du, and now we can take the antiderivative like we did on all of our other problems before. So we're going to have 1/3 u cubed plus c. Final step is going to be plugging in what u is back into your antiderivative. So we're going to have 1/3 times 5x squared plus 1 cubed plus c. For our second example, we also want to identify the pattern f of g of x times g prime of x. So we're looking for an inside function and an outside function. Since we have x cubed plus 1 inside the square root, we're going to use that as our u. X cubed plus 1 is u, and so we write that du equals 3x squared dx. So our problem is that our du is missing, well, we don't have everything we need. We need to have a 3 here in order to have a full du, which we can do, except we can't just multiply by 3. You have to keep the problem the same. So if you multiply by 1/3 on the outside, that will keep your problem exactly the same. So we can rewrite it as 1/3 the integral of 3x squared, square root of 3x plus 1 dx, and then rewrite it in terms of u. So we get 1/3 the integral of the square root of u, which we can rewrite with fraction exponents. So then now, when we go to take the antiderivative, we're going to have 1/3 times 2/3 u to the 3/2 plus c. And the last final step is plugging in what u is into your antiderivative. Okay. So for the same thing, practicing, finding the pattern, and using the result to evaluate. So we're going to have u be the part that's inside the square root, because the square root is your outside function. So u is going to equal x squared minus 16. And we want to find the du, the derivative of that. So that's going to be 2x times minus 0 times dx. And from there, we can look at our original function and say, okay, I have x, I have dx, but I'm missing the 2. So I need to multiply by a 2 here, and then you have to do the reciprocal thing on the outside, so multiply by 1/2 there. So I can rewrite the integral as 1/2 the square root of x squared minus 16 underneath 2x dx, rewrite it in terms of u, and then rewrite it in terms of fraction exponents. Now I'm going to take the antiderivative, so we have 1/2 2 u to the 1/2, and the final thing is to plug u in and change that fraction exponent back to a square root. For number 4, this one's a little bit trickier, but we have a secant of 2x and a tangent of 2x, so the thing that's inside is our 2x. Our derivative is very, very easy. We have 2 dx. And since our integral doesn't have the 2, that's easy to add. We're going to put a 2 and a 1/2 when we rewrite the integral. So when you go to put it in terms of u, we have 1/2 secant u, tangent u, du. Where the 2 and the dx become your du. Now we're going to do the antiderivative. The antiderivative of secant x tangent x, or secant u tangent u, is secant u plus c. And then the last thing to do is plug in what your u is. 1/2 secant x squared, secant 2x plus c. And that's it. For number 5, this one gets even trickier because we don't have an inside function until you realize that the derivative of tangent is secant squared. So what we really want to do is rewrite it so that our function looks like tangent of x squared times secant squared x dx. So now that we have that, we can identify that u is the tangent function and our du is the secant squared x dx. So now we can rewrite our integral to be the integral of u squared du, and then our antiderivative is going to be 1/3 u cubed. So all we have to do is plug in our u, and we're going to get 1/3 u tangent x cubed plus c. And then our last example, it's important to notice the relationship between sine and cosine. Sine is the thing that's squared, so we're going to make u equal to the sine of x, and our du equal to cosine x dx. So the integral is going to be 1/u squared du, and change that into negative exponents. And then we have the antiderivative, add 1 to the exponent and do the reciprocal -1 over 1, 1 over -1, and then write it in terms of positive exponents, and then plug in what your u is. And that's it for our easy substitution problems. These are the 6 problems from your homework, so hopefully those are easy to be done now that you've watched this video. See you in class.